look at the front side of this worksheet, if you load watermelons on a truck that already has 24 melons, and you're loading 4 melons per minute, the explicit equation for linear is mx plus b. So it would be y equals 4x plus 24. And the recursive, we always state the first term, y sub 0 equals 24, and y sub n equals y sub n minus 1 plus 4. Everybody understand that? So the recursive equation, y sub n just means any year the value or the amount of watermelons on the truck for any year. So y sub 16 would be year 16, y sub 18 would be 18. How many melons are on there in the 18th year. So to calculate how many these are minutes, right? To calculate how many melons there are in the truck for any minute, for instance, y sub 10, in 10 minutes, how will you calculate how many melons are on the truck? Y sub 10 minus 1, which is y sub 9, plus 4. There's a problem with that. I don't know how many there were in 9 minutes. You got to go back to 8 and 7 and 6 and 5, all the way back to the beginning. Yes, Presley? Yes, that's exactly where we're headed. Yeah, it's this. You can jump straight to that term if you want. If you want to know the 10th term, plug 10 in there. 4 times 10 is 40, plus 24 is 64. So both formulas have their uses. Recursive formulas are really good at filling out charts. Explicit formulas are really good at jumping into the future or even into the past. So the next question asks, some of you aren't paying attention. Some of you aren't even in your right desk placement. So would the graph of this equation be a solid line or a dotted line? Dotted. And this is kind of weird. We would probably, I can't carry 4 watermelons at the same time, so we would probably put 1 watermelon on the truck every quarter minute, so every 15 seconds. So this would be a series of dots every 15 seconds. Okay? So the next question, how many melons will be on the truck after 4 minutes? These are times. All you have to do is plug 4 into there. The recursive formula is not the way to go here. You want the explicit formula. We want to be able to take an x value, stick it right in the formula, and jump ahead and find the answer. So if you plug in 4, 4 times 4 is 16, plus 24 is 40. 2.25 minutes. That you cannot plug into the recursive formula. There's no way to get that using the recursive formula. The recursive formulas do not allow you to break up the inputs into fractions. It just doesn't exist. The recursive formula will jump straight from 2 minutes to 3 minutes, nothing in between. So you can plug in 2.25. 4 times 2.25 plus 24 would be 33 melons. With an explicit formula, can I go back in time to a minute ago? Yeah, just plug in -1. So 4 times -1 plus 24. So 1 minute ago, there were 20 melons on the truck. Is everybody okay with this? All right. And then 2.75 minutes ago, 4 times -2.75 plus 24 is 13. One at a time, 1 melon at a time. 1 melon every 15 seconds. No, we just interpreted it differently. I can't carry 4 melons at the same time. So it's dotted, but it's dotted every quarter, not every one. Yeah, technically it should be stepped, you're right. So one of the nice things about the recursive formula, or sorry, the explicit formula is it allows us to talk about those individual watermelons. The recursive formula in this case doesn't. There's no way to get individual watermelons. You have to talk about them in terms of fours. But even the explicit formula has some restrictions. If I plugged in, say, 3.3, 4 times 3.3 plus 24, that doesn't make any sense. 3.3 minutes from now, there will be 37.2 watermelons. 2/10 of the way on. Yeah, yeah. Just doesn't make sense. Another problem is, eventually, if you go far enough back in time, there were negative watermelons on the truck. Yeah, that's a problem. So even the explicit formula can run into issues, domain issues, decimal issues. So there are all sorts of problems that you have to deal with. Okay. Um, Down here. When will the truck have the following amount of melons? What's different about this? Those are y values. So plug this in for y. 48 equals 4x plus 24. Subtract 24 over. 24 equals 4x. Divide by 4. X equals 6. Okay, I'm lazy. I never, ever want to do that again. No, you don't want to use the recursive. What's a faster way to find that? Stick it in your calculator and look at the table. So we go into y equals. Well, trust me, you're going to want to do this. Plug in 4x plus 24. Second table. And then I just need to go down until I hit. So the first one was 48, and that would be 6. Now there is another problem with this. Oh, that's not what I wanted. The other issue is we could go all the way back. How long ago were there 4 melons? Go back to -5 minutes. So the answer to this one is 5 minutes ago. I just plugged it into my y equals and then pushed second table, and I just went around until I found y equals 4, which is -5 for the x. Right. This one's pretty easy. How long ago were there no melons on the truck? 6 minutes ago, but that is a little bit tougher. 33 melons. So one thing you can do, well, it doesn't really work that way. That's true, and I just want to show you right here. I can get really close. At 2 minutes, there were 32 melons. And every 1/4 of a minute, a new watermelon gets put on the truck, so that would be 3.25. Another thing you can do, if you push graph and then push trace, as long as your domain is big enough, you can plug those numbers in. So I plug in 3, 3 is too big. I plug in 2, 2 is too small, 2.25 gives me 33. Now, did everybody see that? Watch. Some of you weren't paying attention. You want to know how to do this. I push trace, and I enter 3, and I get 36. That's too big. So now I plug in 2, and it's too small. 2.25, 33. But you can only use trace if your domain is big enough. If I try to plug in 15 and hit enter, it says error. I picked a number that didn't fit on the x-axis. If it doesn't fit on the y-axis, the calculator doesn't seem to care. But if you want to, let's get out of that. If you want to plug in a number using trace, your domain has to be big enough. So if you wanted to find 15 minutes or 15.5 minutes, you'd need to change your window so the x max went above 15. And then it will regraph it, and it will allow you to plug in 15. And you can see how many melons there are. Okay? On the next problem, on a long road trip, a car with a 22-gallon gas tank burns 4 gallons of gas per hour. Is that going to be a solid line or a dotted line? Solid. So is explicit or recursive better in this case? Explicit is definitely better, is a solid line. So the recursive equation, y sub 0 equals 22, and y sub n equals y sub n minus 1 minus 4. To find any hour, take the previous hour and add or subtract 4 from it. What would the explicit equation be? Negative 4x plus 22. And same thing here. These are x values and these are y values. Okay, is everybody good with that? We know how to solve the rest of those. Go down to exponential. Exponential. Right now, an apple tree has 64 ripe apples. Each day, 25% more ripen. So that would be y equals 64 apples. And if we increase 50%, that would be 1.5 to the x. Oh, 25. Sorry, we're increasing 25%. 1.25 raised to the x. So that's 100% of the apples plus an additional 25%. Does anybody not understand the 1.25? Okay. So the recursive equation, y sub 0 equals 64, and y sub n equals y sub n minus 1 times 1.25. Would the graph of this equation be a solid line or a dotted line? Dotted. Can you have a partially ripe apple? It's either ready or it's not. It's either ripe, almost ripe means not ripe. So it's either ripe or not ripe. Okay, at some point it becomes ripe. As soon as the apple starts growing, it's not ripe. And until it's ripe, it doesn't get counted. So this is either a yes or a no. And again, technically it should be steps, right? Should be a step graph, not a dotted graph, but that gets more complicated, so we're not going to worry about it. Okay, this is pretty easy to do. How many apples will be ripe after 2 days? You just take that as an x value and plug it in. So in your calculator, 64 times 1.25 raised to the 2. 100. Okay? But these are harder to answer. How do you find a y value of an exponential equation? Well, let's set it up this way. 400 equals 64 times 1.25 to the x. Well, let's try it. We're going to divide by 64. So take 400, divide it by 64, and we end up with 6.25 equals 1.25 to the x. Now what? What's holding the 1.25 and the x together? They're not multiplied. It's an exponent. How do you undo an exponent? You square root it. So we're going to x root it. So 1.25 equals the x root of 6.25. Did I make it any easier? No. And you have to remember, every square root is different. Every root is different. A square root acts differently from a third root or a fourth root or a fifth root. And especially if there's a negative number in there, you cannot square root a negative number or fourth root a negative number. So it really complicates things, and we didn't make it any easier by taking the x root. The x root doesn't exist. So we're sort of stuck. We just need to guess for now. Matrices aren't going to help us. So let's go back. Let's go back to the original problem. Let's look at this. We can plug 64 times 1.25 to the x in the calculator, and if it's a nice number, the table will tell us. If it's not a nice number, at least it will tell us where we want to look. So go into y equals 64 times 1.25 raised to the x, and then go into table, and we want to know how long does it take to get to 400. So I'll go down a little bit. Shouldn't take too long. All right. When I plug in x equals 8, I get 476. Do the decimals matter here? Oh, sorry, 9. But the decimals don't matter. You round everything down. Even if it was 306.9999, you still round it down because it's not a fully ripe apple, so it doesn't get counted as an apple. When you're dealing with people, you can't have half a person. Even if you're really short, you're still a full person. So if you are dealing with whole items, you always round down. You never round up. In fact, just forget that the decimal's even there. Okay, so this is important. Some of you are working off to the side. Watch this. 10 gives me 596. Oh, sorry, an 8, that doesn't do us any good. 8 is 391. The answer, just pay attention to what I did. Oh. Didn't I? No, you round the decimal down. So the answer is somewhere in between here. Is it going to be closer to 8 or closer to 9? Closer to 8. And here's where the guessing comes in. That gives us a really good place to start. So we go back to our calculator. 64 times 1.25 raised to the 8.3. That was too big. So second, enter, change that to a 2. That's not enough. We need it to say 400 point something. So 8.21, not quite enough. 8.22, there we go. That's close enough. Now, Jimmy, yours is probably more accurate. But that's, as long as you get 400 point something, you'll be okay. So 8.22 days. How long does it take? Because not all the apples are ripe at the same time. Right? They ripen throughout the day. So 22% into that 8th day, well, into the 9th day, then there are exactly 400 apples ripe. But today you're going to be guessing. Next time I will teach you how to find the answer. You won't appreciate it. No. Okay. Looking at the next set. We have a pond used for irrigation that has 36 acre-feet of water. 15% of the water is used each week. So y sub 0 equals 36 acre-feet. Y sub n is equal to y sub n minus 1 times 0.15 would be keeping 15%. 1.15 would be gaining 15%. 0.85. That's how much is left. If you lose 15, you keep 85. Does that make sense? Okay. The explicit equation y equals 36 times 0.85 to the x. Solid or dotted? Solid. The water is always leaking out. There's no way to take water out in chunks. Even if you had a bucket, right, you're taking it out in very small amounts. Like water going out of a tap. Good. So determine how much water will be left after 4 weeks. All we do is plug 4 in there. What would you do down here? Use your table, figure out the range of where you need to be, and then guess until you're within 1 acre-foot. Within 1 acre-foot will be good enough. Well, I guess you'll have to match those decimals there. But there is a way to solve for x in the exponent. We just haven't learned it yet. And, well, we're going to study those later on, but I'm going to do you a favor and teach it to you, not today, but I will teach it to you before we get to that chapter, because it will be very valuable. It's something you want to know how to do. All right, so you have the rest of this page and the back side to finish. Good luck. How are you doing?